we're looking at. This is, you've seen him before, your classic normal distribution, right? And the one we're going to look at first is sometimes called the standard normal distribution. And the standard normal distribution is what you get if you took all your data and turned them into z-scores and made a histogram of them. It would look like this. The mean, mu, is 0. So think of that as just x bar is when it's a sample, and mu is when it's a population. But they're both still a mean. So the mu is 1, and the standard deviation, that's sigma, right, is 1. So mu is 0, and that standard deviation is 1. Now, one of the questions that we're going to use to do SALT is we're going to find what's the probability that z is less than or equal to a number like 1.3. Now, can you remember when we did it, we had a 1 standard deviation, 2 standard deviation, 3 standard deviation. Remember those guys? So if you wanted to do that, it was 68, 95, 99.7. Remember those guys? Well, we're going to do something a little bit more precise than that. Can you imagine 1.3 is about here? You are going to find what's the probability that you would get a z-score less than or equal to 1.3. So we're basically finding what's the chance that you get z-score less than that. And the good news is it's all done by SALT. So you just need to know what to type in. And let me show you what it is, right? So straight out the homework, let's do a picture. Gotcha. Right. So let's suppose I wanted to know the probability that z is less than z star. That's a weird way right now, but basically the first question is z less than 1.96, z less than -2.33, and so on. My one was z less than 1.3. So you hit the use SALT. So I'm writing that down. So you hit the use SALT button, and this will appear. I'm going to have to shrink it down a little bit. Boom, 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 boom. There we go. Doesn't that look kind of sort of like my picture I had a minute ago? Now, we want it to be less than. So you either use left tail button, right tail button, or between. Those are the three. You're not going to get any questions with the both much. But you are going to get left, right, and between. Now, I want less than a number. Do you see less than left-tailed? That's the easy way to remember. Less left, right? L and L. Less than left-tailed. Now, it's a normal distribution. The mean is 0. The standard deviation is 1. Don't change those. Go down here, rub out what's there, and type in 1.3. And the answer that you're looking for is that guy there. See the 0.9032? That's it, you're finished.
So then would the right tail be for greater than?
You are correct. That's exactly what it would be for. I'm just writing this guy down, 903. Let's do a less than, right? Just to show you. Let's do all three situations, because that's really what you're going to get, right? Less than, more than, or between two numbers, right? That's the most common types of questions. So I would like to know what's the probability that you get bigger than 2, right? So Z is greater than 2. So I go and I do a right-tailed for bigger than, and I'm putting in bigger than 2. And the answer is quite tiny, isn't it? 0.02. So I'll write that one down. probability Z is greater than or equal to 2, ends up being 0.023. I'll do it into 3 decimal places. Now, the third possibility is that sometimes you're being asked to do a between, right? So a between, like, what's the chance that you get a Z score between, let's say, -1 and positive 1.1, right? So you want to be less than 1. Oh, I said -1, didn't I? So less than -1 and greater than 1.1. What's wrong with it? Oh, it's a between. So -1, got it back to front. I was right the first time. There we are. Can you see it now? -1 to 1.1. The picture it knows what you should do. So if you do it wrong, it tells you, right? So between is bigger than this and less than that. Can you see start number, finish number, right? -1 to 1.1. And the answer in that case would be 0.706. Okay, let's return back to the whiteboard. Show you what was going on there. Greater than 9, less than 1.3, the answer is that. So that was less than, and we did, right, left tail. Now you wanted bigger than 2, that's a greater than, right? And the greater than, you chose the option right tail, okay? And the between one, well, mathematically the between one gets written like that. That's the notation for between. And you use the between choice. Do you feel comfortable about how you can use SALT to get what's the probability you get a Z score less than something, greater than something, or between something, right? So far, so good. Right. Now, what they can do next, and that's really just the next stage up, is imagine that you've got a mean IQ of 100, remember that one, and a standard deviation of 10. And maybe it'll be written like that, right? But they're really equivalent information. And I want to know what's the probability that you have an IQ score greater than, was it 156? My memory serves me, right? I think it was that, 156. And we are going to figure out how to do that using SALT. Now, that is extremely rare. You are going to be looking at 0.00, who knows? In fact, it might be so small that it's so close to 0, SALT just says, it's 0, right? So, going back over to the screen, and you have to do a slight adaptation. Not a lot, but a little adaptation. Right, you see the normal distribution? Keep that. Now, if the mean is not 0, that's the only time it's 0 is when it's a Z score. You write down the mean, in this case, it's 100. And the standard deviation is 10. Now, I want to get greater than, and the number we want to see is greater than 156. And do you see the answer down here is 0? Now, if I hit that little, warning symbol triangle, it says it should be a number greater than or equal to 0.00001 and less than something, right? So basically it's saying this number has just got too many zeros in it, right? It might have 8 zeros, but I can only do 6. So if you round it off to 3 decimal places, that answer is that. So let's suppose I want to know what's the chance that you have an IQ greater than 120? Oh, the chances of that happening are about 2.275% of the population. So all you need to know is the mean and the standard deviation, and I can tell you pretty much anything that you need to know. So let's make up one and do a whole load of questions, one after the other, using salt. So you didn't know this because it's not true, and I just made it up. But the average height of a Scottish person is 65 inches. And the standard deviation is 5 inches. And I want to know what's the probability, you could say what's the percentage, of Scottish people who are bigger than or equal to, we'll make it 72 inches, right? 72 inches. Okay. I want to know the percentage of Scottish people who are less than 58 inches. And I'd like to know the probability that you choose a Scotsman at random, and they're between 60 and 63 inches. So we are going to use salt to find what percentage, and I'm using the word percentage and probability interchangeably here, right? The probability is you get Scotsman greater than 72, right? If you turn that into a percentage, that's a percentage of Scottish people who would be greater than or equal to 62. So the only thing I need is that, and I need to make the assumption that the distribution of Scots heights is symmetric, right? So if this data is skewed left or skewed right or weird, this doesn't work. But most data in many situations is normal or normal enough. So greater than 72, less than 58, or a between. So I got the guy here. Right? You hit the salt button. You go to the mean and you change it to 60. Whoops, let's get this right.
We can't see.
Okay, thanks, Maggie. Here we go. Right, so we're looking for what percentage of Scotsmen, right, are over 6 foot, right? So I want a right tail, right, bigger than. The mean is going to be 65, and the standard deviation is 5. And the percentage of Scotsmen who are greater than 72 goes there. And the answer is, what, about 0.081, which is about 8.1%. Now, what about percentage of Scotsmen who are less than, left-tailed, 58 inches? And the answer, oh, by sheer coincidence, also happens to be 0.081. That's just a coincidence. And then we want between 60 and 63, and that better not be the same number, because that would be a real weird fluke.
84.
So I've got 60 here, and on this side, I'm going to put 63. And the answer is about 186. So basically, I know everything I need to know about a population. If it is normally distributed, right, if the data looks like a hill, and you just tell me the mean and standard deviation, I can tell you anything. I can tell you that in this case, about 8% of Scotsmen are over 6 foot, about 8% of them are under 58, and about 18.6% are in this range.
668.
I'm going to mute you for a second. Getting background sounds. There we go. Now, based on the fact that SALT can do almost any of these types of questions, you can analyze all sorts of things. Let's suppose we have a university that has an entrance exam, which I don't think is that common in America, but it might be. Do they have entrance exams in some high demand places, right? So you take an exam and depending on how well you do, they let you in or not, right? So let's suppose that they have an entrance exam and the mean score that people get is 300. And that the standard deviation, let's say, is 13. And let's say that this college only lets you in if you get a score that's greater than or equal to 309, right? So you need to get 309 or better in their exam, right? And you can see that the average score that people get is 300. So that means a lot of people are never getting in. But we want to know exactly how many people that would be. So the probability that you get a score greater than or equal to 309. Right? So back to our SALT. This number is the mean. So in this case, it is 300. And the standard deviation in this case is 13. And we want to know greater than, so a right-tailed, and we want to know greater than 309. And the answer comes out as 0.244. So if you want to interpret that in English, you could basically say about 24.4% of the applicants, right, get in. Does that make sense? So if you had a university, might they say things like only 1 in 10 of our applicants get in, right? In this place, won't they say only 1/4 of you get into the university, right? So that would probably be a university with quite a high standard to letting you in, right? And if you go to some of the less reputable ones, 90% of applicants get in, right? That would be a sign. So if you're looking at a university and it's one of your things that is on your radar and you're thinking about where should I go, let's say you're flexible. If you can only stay at home, aren't you kind of UW or you do some of the ones that we do here, right? That's for commuting purposes, that's it. But let's say you could go anywhere, right? You're free and you can go to any city. Look at things like the percentage of applicants who actually get in, right? And if it's a small number, that's a reasonable sign, isn't it? That they have high expectations. If you can, look at the percentage of graduates who get a job in the field that their major was in, right? So if you become an engineer, how many got a job as an engineer within 12 months of graduating? That's always a very good indication that whatever they're teaching you transfers into getting a job, right? So if you have a university and they teach you, the major is social sciences is your major. And then they say 5% of the people who graduate here actually get a job as a social scientist. That's probably not a good place to go if you want to get a career as a social scientist. Now, that doesn't mean they don't get a job. I mean, they get a lot of degrees are not actually used in the person's job. A lot of people end up in HR or in business or advertising or whatever, right? And nothing wrong with those jobs, and they're really good paying jobs. But if you're a scientist, you probably want to do something in science, right, when you finished. And that's my little rant. Let's look at some questions and what they look like in your homework, because sometimes they phrase them in a weird way. Just sometimes. Right. Okay, I think this question is pretty straightforward, Jude. I'll make it a little bit bigger. If I hit the salt button, what would be the mean and standard deviation for all these questions in question 4? What number will be the mean and what number will be the standard deviation? There is a clue here. There's one of the clues. There is a
0
clue.
and 1.
Yeah. If you ever see Z or standard normal, it's going to be a 0, 1. Now, these are the answers. God, I hate it when they do that. Go away. Don't need answers. Go away. Right. At last, answers are gone. Right. So if you were doing this one here, right, less than negative 1.9, you hit salt. You do less than negative 1.9. This would be your answer. And then you just, boom, right? And 4 decimal places, 1, 2, 3, 4. So make sure you do that, because web sign can be fussy, and you're good. Now, wouldn't that be left-tailed and left-tailed, right? If I wanted to get D, left-tailed or right-tailed, what should I use to do D?
Right tail.
Right. And won't that one, I think that one's pretty obvious, is it not, a between? Here's another bunch of the same questions. Now this one is to doing with pulse rate of adult females. Did you know that it was 73, at least in this set of data, and 8? So when they tell you the mean, won't that be 73 that you'll use? And when they tell you the standard deviation, won't that be 8? For question 8, left-tailed, right-tailed, or a between? What should I use?
Left.
Question left. So I'm going to go and find the salt button. Here we go. And 73 and 8. So you make this mean 73. You make this standard deviation 8. And then the question was less than 65, left-tailed. Less than, left-tailed, 65. And the answer is that one. So 4 decimal places, yes, 4 decimal places, so that changes to a 7. So the percentage of adult females with a pulse rate less than or equal to 65 comes out roughly about 15.87%, which is 0.1587. And in this case, won't I just do a right? In this case, won't I do a between? A lot of deja vu here, isn't a lot of the questions are basically the same question with different choices and numbers, of course. Question 7 is a mean of 600 and a standard deviation of 120. And then you plug them in and you get these guys. Now, in this case, average weight of males is 190, standard deviation is 28, and you might want to know greater than 176, say. Let's find salt, and what do I want? 190, 28. 190, 28. Then I just want to find out less than. Less than is less than 232. And the answer is almost everybody, about 93% of them. Are you comfortable about these questions where they tell you the mean and the standard deviation, and then they basically ask you to use SALT to find the probability that a person is bigger than, less than, or between two numbers? Have you noticed that the stories might change, but pretty much everything else stays put? In this question here, it's the same question, but haven't they made it more like English? So this one is clearly the between. This is more than, and this is less than, right? And so you should be able to use, God in Himmel, $450 is the mean average, and $150 is standard deviation. How much does it cost you, if you want to share, for all your textbooks?
Mine was like 300 something this quarter.
Okay, so that's pretty. Are you including WebAssign? Because that's another 100 on top of it.
Yeah.
Okay, that's not bad.
Mine
I know.
was a robbery.
Oh God, what did you get?
It was pretty close to the mean. That's all I'll say.
Right, and close enough that you didn't like to pay it, which would be quite natural if you did.
Yeah, exactly.
Right. You should, if you think this is bad, I'm going to depress you. University books are even worse. So if you've got any of your family at university, the argument which has not convinced me, but I'll go with it anyway, is that a lot of university books have a very, very small market. You know, if you write a romance novel, right, you can sell in millions. If you do an advanced calculus book, you know, university or, you know, graduate level, the person who makes that book will probably spend a lot of time, right? A lot of time on it. And the publishers are going to want to make a lot of profit. So the books are just extortionately expensive. That's the bottom line. But I sometimes feel that they're more extortionately expensive than they could be, because you are a captive audience, aren't you? Now, if you go to UW and they say, you need to get the Advanced Electronic Engineer book by Brooks. I'm making this up, right? Aren't you going to have to buy the Advanced Engineering book by Brooks? And if it costs you $600, you're going to be sweating blood, but that's what you have to pay. Yeah. So it feels a bit like what I do when I have to go to get my car filled up with gas. I mean, it's not like I can say, well, I'm just not going to use gasoline anymore, or I'm going to stop eating, although that might be a good thing to do. Okay, so back to focus. Here is the rainfall for a city. The mean is 22 and the standard deviation is 10. And we're going to find the probabilities of these particular events. Right? Let me make up one on my own then. Okay. So let's suppose that I lived in a particular place and the average rainfall was 32 inches a year, and that the standard deviation was 4 inches. Right, so in a year, 32 inches, right? And this data has been collected, not that you need to know this for the story, but over the last 100 years, which in America is probably true. Would you agree that in most places they'll have collected data over a large period of time, right? Unless it's some isolated place. And 1 year, let's say last year, they got 39 inches of rain. So let's find the probability that you get greater than or equal to 39 inches, which is basically how unusual is 39 or more, right? Now we're going to do this in salt, which I will, and I'll do it, I'll just do it myself and you just trust me. So I've got salt in front of me here. Well, I did, and then I hit a funny button and it went away. I've lost it. Okay, I'm having a problem finding my salt button. I'm not swearing, I'm being nice. Oh God, there it is. No, come back. I'm panicking here. How do you get it back? It's there, but it's so small I can't bring it up off my bottom screen because I've got a thing along the bottom that stops me getting to it. If that makes sense to you, which it doesn't to me. Right, I'm closing that window. Maybe that'll help. Yay, I got it. Okay, after all that disturbance, 32 inches is the mean, and sigma is 4. And we are looking for greater than, so that's right-tailed, and I'm typing in 39 inches. Anybody got a gut feeling for how small that answer is? Want to take a guess, and that's pretty much all it is. Do you think it's 20% or 10%, 1%?
0.26.
Oh, pretty good guess. 0.4.
Hmm.
That's about 4% of the time. Which, if you think about it then, since this is a 100-year period, wouldn't that have happened 4 times in the last century? Does that make sense? 4%? What, roughly every 25 years, you're going to have a really exceptionally rainy year. Agreed? You could do it the other way where, 4 times of the year, aren't you going to get exceptionally dry years? Has anybody heard the phrase, once in a century? So they say, this weather, whatever this weather is, right? Amount of rain, too much rain, whatever it might be, happens once in a century. Now, if that was an article in Bremerton, right? Let's suppose we get a really, really bad year and they say something like, this is the most rain we've ever had in Washington as long as records have existed, right? So it's a 1 in 100 year, once in a century. And a lot of people put a lot of weight on that, thinking, ooh, bad things, weather's changing. Once in a century, that's not luck, something's going on. Well, here we go. Would you agree that there's 100 cities in America? At least. Agreed? Every single year, won't one of those cities be getting a once in a century weather thing? So if you want to do that, can't you just have a big news story? Cincinnati has had the hottest weather on record, right? Anchorage has had the coldest recorded temperature in a century. Well, aren't you going to get that every single year, right? If you have 100 cities. I don't know. There's probably a lot more than 100 cities in America, right? So can you imagine that everywhere, if you put them in a group, isn't somebody somewhere going to get a 1 in 100-year thing happen? In fact, isn't that what you would expect if nothing exceptional was going on? Wouldn't you just expect 1 in 100 to happen to someplace, somewhere? And so I'm really skeptical when people tell me it's the worst temperature in 100 years, or it's the coldest, or the wettest, or the driest. Because I'll just say, yeah, that was your turn. And next year it's going to be Chicago. And next year it's going to be New York. Because somebody's going to get it, because 1% of the time means 1% of everybody. So if there's 100 cities, that's one. Now, to finish this question, we are going to do a medical story. So I have to make things up because I'm not a medical person. So if anybody is in nursing, your potassium level is important. I have no idea why it's important, but it's important, right? Like your calcium level is important and your iron level is important. So in my made up story, the potassium level is important, right? And now we are going to look at the made up mean and the made up standard deviation. Now these are made up by me because I can't find the answer. But you know how they record it? Don't doctors in hospitals, they record potassium levels all the time, right? So there's probably a big, 100,000 data points where everybody's been tested. So in this world, 32 units of potassium is the mean for a normal, healthy adult, and the standard deviation is 2. And we are going to set up one of those things. Have you ever had blood test where they have a little line like this and you have your score, and depends on where you are, you might have a normal, which is from here to here, potassium level, right? That would be normal. I'll make up my own names. If you're in this region here, or if you're in this region here, this one would be, you've got a high potassium level, right? You've got a lot more potassium than typical, right? And down here, it would be low. And then last but not least, I'll change to green. If you're anywhere in this region, I'm going to put the word danger, right? Isn't that dangerously high? And if you're anywhere in here, isn't that dangerous and low? So what we are going to do is we are going to tell you, based on this information, what these numbers are. So in the normal range, we're going to have 80% of the population. And then in this range here, and this range here, we're going to have, what's that, 20, 10 left. So we're going to have another 7%. And then right at the end, we're going to have 3%, right? So these numbers are going to be based on these arbitrary decisions. In other words, if you're in the top 3% of your potassium level, I'm going to call that dangerously high, right? And the doctor's going to say, your potassium levels just came in. I'm not happy with it. You're going to have to come in. This could be dangerous. I'm going to give you this pill medication that'll reduce your potassium level. And I might want to do some other tests, because I know that when your potassium level is really high, it might be a heart issue or it might be a kidney issue, and I'm going to test for it, right? That's what doctors do. But don't they need these numbers, right? So Let me show you how you get them. So I want to know the bottom 3%, right? I want to know what number goes here. So I'm going to put in, before I forget, the average is 32 and the standard deviation is 2. Now I want that bottom piece that's shaded to be 3%. So I don't put any number in here. What you do is you put the answer, and A, the number that's above it is how much your potassium level should be. You see how I made that 3 and this changed? So the answer that I'm looking at here is 28.2. Now, the next number up is 10%. So I just go here and I make this 10%. These are called percentiles, by the way. Oh, that's 29.4.
Why is it 10% instead of?
Oh, 3 plus another 7 takes me to 10%.
Okay, gotcha. Thank you.
3%, 7% more. Right. Now, the next number is at 90%, because you do 3, 7, and 80 more. That's 90%. So I'll make this 90. It's called the 90th percentile. And it's now 34.6. And then the next number is at 97. And that ends up being 37.8. So all those boundary points that we were after are here. Now, since there's a lot going on, I'm going to do it again. And it's going to be, if you get a potassium level less than 28.2, you're dangerously low. From there to here, which is 29.4, it's probably nothing to be worried about, right? But it's low. If you go from here to 34.6, it's totally okay. That's what we'd expect. If you do to the 37.8 mark, it's probably nothing to worry about, but it's a little bit high. And if you are bigger than this number, then you are dangerously high. And that's essentially how all those blood tests that you get, can you see how they figure out what is considered high, what's considered very high, dangerously high, and so on, what's considered the normal range? Now, I get blood tests, God, all the time, so I'm really into numbers and I like looking at it, but now you kind of know. Now, I'm saying the answer is 87 and 3. Do you know these are adjustable? Couldn't I say, if you're in the middle 90%, and that's normal, and tweak these accordingly, right? Or middle 70% and tweak these a little bit different. That I don't know. That's probably something that if you're in the nursing or the medical field, you'll know how to do it. But once you've set this up, don't you just need to know the mean and standard deviation and how much people should be percentage-wise in each group? And now you've got one of those. Has anybody had one of these? Anybody want to share? Ever had a blood test and you got, it was normal, it was high? I guess I'm the only one that gets these done all the time, so I'm kind of into it. So that's how they do it. And why is a certain blood pressure too high? That's how they found out, right? What is considered a high blood pressure? And you know they do it different for men and women, right?
Yeah, I always have my blood pressure done.
Right. So if you ever noticed, well, maybe you do it yourself with a little home machine, which I have, but if you go to the doctors and you ask them, is that good? They'll tell you, actually, there's 2 blood pressures, systolic and whatever the other one's called.
Can I ask a question about that problem before
Mhm.
So the first part where you did the 3%, the 7%,
Yeah.
Like that all adds up to 100, right? But
Yeah.
the bottom, am I doing my math wrong? Is that supposed to add up to 100 or is it?
What, these numbers here?
Yeah, is that supposed to
No,
add up
they're
to
not
100?
meant to add up to anything in particular.
Okay, thank you.
Right. If they ended up being close to 100, it was just a sheer coincidence. Okay, that's a good time for us to finish. You have one homework to do, well, 2 sections, but chapter 8, one chapter to do, I guess that's what I'm trying to say. And 1 test, all to be done by Sunday. So, last name and bye-bye. No class tomorrow, that's what I was meant to mention to you.
I have a question about number 12.
Okay, let's, right, if you're good, you can leave. I'll go and look at question 12 for you. Let's see. Assume that the total, whoops, let's get that one sorted out. Assume that the total cholesterol levels for women in the 30 to 39-year-olds are normally distributed with a mean of 203 and a standard deviation of 38. Find the cholesterol value. So it's kind of the question I just did.
Yes,
right?
I understood how to do the first part and I got that
Uh-huh.
correct, but the second part, I guess I just blanked out and I'm I'm confused.
Oh, you won't like the answer. It's 20, it's whatever the percentage was. So if your question was 27%, we call that the 27th percentile.